Hello, in this video we're going to use the Gaussian method to solve the inverse matrix for a 3 by 3 matrix. So we want to solve the inverse matrix of A. So here's matrix A. We want to find its inverse. And the way we're going to do that, we're going to create an augmented matrix where the identity matrix is on the right and use row operations until the left matrix becomes an identity matrix. The inverse matrix will then appear as a right matrix. So again, to set this up, we're going to create an augmented matrix where over here on the right we have the identity matrix. We got ones along the principal diagonal, zeros everywhere else. Here's matrix A. What we're going to do is we're going to try to turn matrix A into an identity matrix by using row operations. And once we do that, what we have over here on the right hand side will become our inverse matrix. So step one is to get a 1 in row 1, column 1, and then zeros everywhere else. Then we want to get a 1 in row 2, column 2, and then zeros everywhere else in that column. And then in row 3, column 3, we want to get a 1 down here, and then zeros everywhere else in that column. The allowable row operations, any row can be multiplied by a constant, and any multiple of a row can be added or subtracted from another row. So let's begin. So the first thing I want to do is I want to get a 1 where this number 2 appears, so we can multiply row 1 by 1/2. When we do that, we get the following. And notice I'm multiplying this 1/2 across all of these 6 values, these 6 elements. And the next step is we want to get zeros everywhere else in column 1. So our next step here, we're going to multiply row 1 by 3 and subtract from row 2 to get the following. So we're going to have 3 minus 3 times 1 is 0. Then we're going to have 4 minus 3 times 1.5, which is minus 1/2. And then this is going to be just 0. And then we're going to have 0 minus 3 times 0.5, which is just minus 1.5. And then nothing happens here or here. Okay, our next step, we're going to subtract row 1 from row 3 to get the following. So 1 minus 1, 5 minus 1.5, and then 8 minus 0. And then 0 minus 0.5 leaves us with minus 0.5. 0 minus 0 is 0, and then 1 minus 0 is 1. Our next step, we're going to be moving into the middle column here, and we're going to try to get a 1 right here in row 2, column 2. And we can do that by multiplying row 2 by minus 2. So minus 2 times minus 1/2 is just 1. Minus 2 times 0 is 0. And then again, continuing that multiplication for the rest of the values here, we get the following. Now we want to get zeros everywhere else in this middle column. So our next step is to multiply row 2 by 1.5 and subtract from row 1 to get. What I'm trying to do here is get a 0 in row 1, column 2. So with this particular calculation, we're going to be left with the following. So again, just multiplying row 2 up here by 1.5 and subtracting from row 1. Row 1 now will look like this. Okay, moving on. So just rewriting that last matrix. We want to get a 0 where this 3.5 is. So to do that, we're going to multiply row 2 by 3.5 and then subtract that result from row 3. So following that calculation, the bottom row will now look like this. And then finally we want to get a 1 here in row 3, column 3. And we can do that by multiplying row 3 by 1/8. And that will leave our bottom row looking like this. So we finally got this left-hand side matrix into an identity matrix. That means that if we did everything right, this right-hand side matrix is going to be the inverse matrix for matrix A. So we're going to say the inverse matrix A is going to look like this. And we can check our answer by multiplying these two matrices. And if we multiply these two matrices, we should just get the identity matrix, and we do. All right, I hope you found this video helpful.